Okay, in this section we're going to talk about composition of inverses of functions, and we're going to define them first of all. As a function whose value at x is f of g of x is called the composite of the functions f and g. In other words, they're composed of one another. You put the g in the f function and you come up with a composite. The operation that combines these, however, f and g, to produce their composite is called composition. Now, things to note: not all functions have inverses, because we're going to find out what an inverse is. And if a function does have an inverse, it will pass a horizontal line test, we'll talk about and what it exactly is. And inverses are denoted by this symbol right here. It looks like f to the minus 1 of x, which does not mean f is being raised to the negative 1 power. It is read as f inverse. So I'm going to try to remember to read it as f inverse throughout the videos. Now, when a function has an inverse, now you're not going to understand this maybe, but I'm going to explain this graphically. It just means they are inverses if f of g of x is equal to x and g of f of x is equal to x for all x in the domain of f, or in the domain of g and f. So in other words, these two things hold. Now I'm going to explain exactly what they mean, because I know you won't really get that until I do show you the graph of what that really means. So inverse functions are found by reflecting the graph around the x equals y axis. Now if I graph this green line right here, that is the graph of y equals x. And I'm going to call that the x equals y axis or the y equals x axis, either one. It just means that every value 1, 1 is on it, 5, 5 is on it, 6, 6, negative 8, negative 8. Those are the points that are on that line. So that's the green line that I put on there first. The red line is my function that I graphed. Now, when I said that you wouldn't understand that thing, here's what I'm talking about. F3 is talking about this blue line right here. Okay, this is actually was done as the inverse of the red function. So the red function was graphed first, which was 2x plus 3. So here's just an example of a straight line, 2x plus 3. F of 0 is equal to 3. Right here, this point that's outlined in yellow. So that's f1 of 0, because your calculator calls it f1 instead of f of x and g of x. So this is the f1 function, and f1 of 0 is equal to 3, but f3, the g function over here, or the inverse, f inverse of 3 along the x-axis is equal to 0. You see how they're exactly flipped? And that's all that definition was saying, was that f of x right here is equal to the g, or the inverse of that. So it's actually, if you just see this, a lot of these you're going to know that you're just going to revolve these, rotate these around the x equals y axis, or mirror image. If you think about taking a piece of paper and folding it right along this line, right diagonally around there, and you drew something on there in wet paint and you flipped it, folded that in half, you would see the other line, and that's really what the inverse is. Okay, now once you see what an inverse really is of a function, you see it graphically, but how do we find these inverses? Here's the steps that you go through to find these inverses. Write the function with y instead of the function notation. So in other words, substitute y in for f of x, rewrite it with y equals and then everything on the other side. Okay, then rewrite it exchanging the x and y around. In other words, write y for x and x for y. Switch them. Then third, solve the equation for y so that you have it in the form y equals. And then finally, replace with the function notation f inverse of x. I said if you want to, and this is, I would prefer that you do this for right now because you need to get used to this inverse notation. But I think that just do it. Okay, for the above example, the red function was the function that I was going to get the inverse of, which is, and I showed you, here's how we did it. We took f of x is equal to 2x plus 3. That was this red one up here, right? Okay. So, to get that blue function and to graph that, what I did was I rewrote this with, instead of f of x right here, put a y in there. Y equals 2x plus 3. Now, rewrite the second equation, this new one we just wrote, with x in for the y and y in for the x. So it becomes this equation, x equals 2y plus 3. Finally, solve for y here. Once I had y is equal to 1/2 x minus 3/2. Now, I happen to use decimals because they were easier to type into the calculator when I graphed it, so that's why you'll see decimals, because 1/2 and 3/2 easily converts to 0.5 and 1.5, and they're exact. So if I had come up with something that I could not convert very easily, I would have just typed the actual fraction in. Okay, now notice that the red line passes the horizontal line test. Now here's the horizontal line test. If I take a horizontal line and I draw it across, straight across, like the x-axis, if I took the x-axis and I moved it up and down along that line and found how many times would it cross that line, that red line, it would only cross it in one point because it's a straight line. Okay? If that's the case, then it's called passing the horizontal line test. Now that horizontal line test tells us that the function has an inverse. If it does not pass it, in other words, if it crosses it in more than one spot, then it does not have an inverse. So I'm going to show you what some look like. Here's one. Here's a function that does not have an inverse. Okay, you're real familiar with this. Here's the y equals x line right here in green. And then I just graphed a function y equals x squared, or f of x equals x squared, here in red. And actually, you think about this, if you revolve this around the x equals y axis, or you mirror it around here, you're going to get a curve up here, but you're also going to get a curve down here. The only problem is that when you do this on the calculator, it doesn't show you the bottom half of it because it's not a function, and the calculator wants a function. So, anyway, if you look at this, here's the graph of what happens to it when you do the calculator. Okay. Notice the blue one, it's only going to show you the positive part because obviously it's going to square it, and you can't do that with the negative. So anyway, the calculator will not show you the bottom half of the graph. So now we're going to do some problems. Okay? Great.